In this video, we're going to go over page 41 of our Math 6 textbook, numbers 1 through 12. Let's begin. Number 1, we need to find, let's take a look at it. Find the GCF of each pair of numbers. So the GCF is the greatest common factor. I'm actually going to write this in my own, actually I'm going to write it over here. Well, I'm going to write it on my own paper. Why not? So this is textbook page 41. This is question number 1, where they want us to find the GCF of 20 and 32. And to find the GCF, what I do is it's almost like upside down, backwards, two-number division. I ask myself, what is a number that I can divide both 20 and 32 by? Now, we can go with a large number, or we can go with a small number. Any number that works. It has to be bigger than 1. Let's go ahead and try 2. Divide both 20 and 32 by 2. So 20 divided by 2 is 10. And now 32 divided by 2 is, let's see, 15. That's 16. And now we ask ourselves, do we have to add another layer? Yes, we do. Add another layer to our ladder because we can divide both 10 and 16 by another number, which is 2. Let's divide them both by 2. If I divide 10 by 2, I get 5. If I divide 16 by 2, I get 8. And can I divide both 5 and 8 by anything? No, that's it. So you may be wondering, do I draw an L and multiply all those numbers? No, because we're looking at the GCF. You only need to multiply the outside numbers. So 2 times 2, which is 4. So the greatest common factor of 20 and 32 is 4. Could you have divided both 20 and 32 by 4 and saved some time? Yes, you could have. But you could have also done it the long way like this. Let's take a look at number 2. Number 2 is asking us to find the GCF of 24 and 56. So I'm going to write number 2 right over here. Let's take a look at 24 and 56. So what can I divide both 24 and 56 by? 2 is going to work because they're both even. It's probably not the best number because they're both so big. But if you're good at multiplication tables, you can try different numbers. But let's go ahead and go with 2, just because I'm having trouble. 2 goes into 24 12 times, and 2 goes into 56. Well, it goes into 50 25 times. It goes into 6 3 times, so that would be a total of 28 times. I can divide both 12 and 28 by 2, because they're both even. 12 divided by 2 is 6, and 28 divided by 2 is 14. And because both of those are even, I can divide them by 2. So I had another layer to my ladder. 6 divided by 2 is 3, and 14 divided by 2 is 7. And there's nothing you can divide both 3 and 7 by, so we multiply these three numbers. 2 times 2 times 2, and 2 times 2 is 4, times 2 is 8. So the GCF of 24 and 56 is 8. Let's take a look at number 3. Oops. Number 3. Number 3 wants us to find the GCF of 36 and 90. So we've got 36 and we've got 90. Well, they're both even, so you can divide them both by 3, but they're also, I'm actually pretty good with my 9s. So 9, 18, 27, 36. 9 times 4 is 36, and 9 times 10 is 90. So, good on me for knowing that the 9s work. 9 times 9 times 4 is going to be 36. 9 times 10 is 90. All right, I am not done there because 4 and 10 can both be divided by a number because they're both even. Divide them by 2. 4 divided by 2 is 2. 10 divided by 2 is 5. And there's nothing that both goes into 2 and 5, so we multiply 9 and 2, which gets us 18. 18 is the GCF of 36 and 90. And finally, number 4. Number 4 asks us to find the GCF of 45 and 75. Ooh, I like this one because it's got 5s in it, and you can divide these by 5. So 45 divided by 5 is 9. 75, well, that's a little harder. That's 5 times 10 is 50. 75 is 15, I believe. Yeah. So, can you divide 9 and 15 by anything? Yes, you can. They're not both even, so 2 doesn't work, but you can divide them by 3. 9 divided by 3 is 3. 15 divided by 3 is 5, and GCF means I multiply those two. 15 is going to be our answer for number 4. Let's take a look at number 5. 28 girls and 32 boys volunteer to plant trees at a school. The principal divides the girls, that's 28 girls and 32 boys. The principal divides the girls and boys into groups that have girls and boys in each group. What is the greatest number of groups the principal can make? So he's dividing them into girl and boy groups. And he wants to have basically the same number of girls and boys. So what you're going to do is, and it doesn't really matter how many people are in the group, so what is the largest number of kids you can have in any given group? They're basically asking you to find the GCF of 28 and 32. It's a GCF problem, a real-life GCF problem. So number 5, we have 28 and 32. And then, well, they're both even. Actually, you know what? I'm pretty good with my multiplication tables. 4 goes into both of them. 4 goes into 28 7 times, and 4 goes into 32 8 times. Look at that. And there's nothing I can divide both 7 and 8 by. That just tells us how many girls and boys are in each group. 7 girls and 8 boys, but that's not what the question is. The question is, what is the greatest number of groups the principal can make? The greatest number of groups is 4. Because 4 times, 1 or whatever is just 4. Anyways, let's look at number 6. Sorry, that's an ugly 6. Number 6. Find the sum of the numbers as the product of their GCF and another sum. So we haven't done this in a while, but basically, we want to make it look like like a setup to a distribution problem, distributive property problem. Don't mind all the craziness I'm saying. Basically find the GCF of 32 and 20. In this case, it's going to be 32 plus 20. Anyhow, what goes into both 32 and 20? Well, 4 goes into both of them, I believe. 4 goes into 32, let's see, 4 times 5 is 20, 24, 28, 32. Oh, it goes into 32 8 times, and it goes into 25 times. I'm good at that. So is there anything that goes into both 5 and 8? Oh, sorry, 8 and 5? No. So what you do is you take this GCF right here, take this GCF, put it on the outside, and then you just put parentheses around those numbers right there. So that's our answer. It's 4 parentheses 8 plus 5. That's how you write it, as a product and their sums. So let's look at number 7. 7 asks us to do 18 plus 27. So let's do 18 plus 27. Number 7, 18 plus 27, and they want us to find the GCF. Well, 2 doesn't work because they're not both even, but 3 works. Pull out a 3. 3 goes into 18 how many times? It goes into 18 6 times. 3 goes into 27 9 times. Is there anything I could do? Pull out of 6 and 9? Yes, they're both divisible by 3. So divide this by 3. 6 divided by 3 is 2. 9 divided by 3 is 3. And that's it. I multiply these two guys. 3 times 3 is 9. Put parentheses around these two guys. 9 parentheses 2 plus 3, or 9 times 2 plus 3. Alright, we are going to be going to the next couple of questions, which are LCM questions, which is the exact same thing except you multiply more numbers with these. So find the least common, well, the process is very similar. It's exactly the same except for at the end. The least common multiple of each pair of numbers. So what's the smallest multiple of both 6 and 12? I already know this one off the top of my head, but let's go through the process. Number 8, we want the LCM of 6 and 12. So do the same thing, upside down division. What can you divide both 6 and 12 by? Well, you can divide them both by 6, but let's go ahead and do it the long way. Let's divide them both by 2. 6 divided by 2 is 3. 12 divided by 2 is 6. And can we divide both 3 and 6 by something? Yes, we can. They're both divisible by 3. 3 divided by 3 is 1. 6 divided by 3 is 2. Can you divide both 1 and 2 by anything? No. So that's going to be where our ladder stands. So what do we do from here? Well, we're looking for the LCM, correct? And so if we see LCM, we are going to draw a giant L through those numbers because we want to multiply 2 times 3 times 1 times 2. 2 times 3 is 6, 6 times 1 is 6 still, and 6 times 2 is 12. So our LCM, our least common multiple, is 12. Let's try number 9. Numero 9. 6 and 10. Find the LCM of 6 and 10. So, you can divide both 6 and 10 by 2. I think that's it. 2 goes into 6 3 times, and it goes into 10 5 times, so we can't pull anything out of 3 and 5, so we draw a giant L. 2 times 3 is 6. 6 times 5 is 30. Our LCM is 30. LCM is kind of nice because it helps you find the least common denominator when you're dealing with adding and subtracting fractions. Number 10, 8 and 9. You're looking for the LCM of 8 and 9. And I don't think you can divide 8 and 9 by anything except for 1. So basically, draw the L. 1 times 8 times 9. 1 times 8 is 8. 8 times 9 is 72, I believe. Yep. So our LCM is 72. And yes, if you can only pull out 1, there's nothing wrong with that. That is the correct answer. Let's do number 11. Almost done, almost done, almost done. We've got 9 and 12. Find the LCM of 9 and 12. They're both divisible by 3. 3 goes into 9 3 times, and 3 goes into 12 4 times. Can I divide 2, 3, and 4 by anything? Nope, just 1. So draw your L. 3 times 3 times 4. 3 times 3 is 9. 9 times 4 is 18, 27, 36. 36 is going to be our answer. Number 12. We've got a word problem. Juanita runs every 3rd day and swims every 5th day. So every 3rd day and every 5th day. If Juanita runs and swims today, in how many days will she run and swim again on the same day? So that's it's a bizarre problem. When you see something like that, that's an LCM problem. They're looking for the LCM of 3 and 5. So, is there any number you can divide both 3 and 5 by? Nope, just 1. So, 1 goes into 3 3 times, and 1 goes into 5 5 times. So you multiply 1 times 3, which is 3, and 3 times 5, which is 15. And so our answer is in 15 days, she is going to run and swim on the same day. And